hour. My name is Kath Hardy, and I serve as one of the leads for our Connected Conservation Community of Practice. Thanks so much for joining us on our monthly webinar series as we kick off 2019 with a really exciting webinar here from the Natural Sounds and Night Skies Division within NRSS. We host our webinars each month. They vary in topics, but the hope is to showcase tools that enable parks to work beyond boundaries and to work with agencies or neighboring partners to do some good work, again, crossing boundaries. I'm going to plug in a couple of links into our chat there. You can learn more about our webinar series in our online toolkit that's open to all Department of Interior employees. You'll see that we've hosted webinars over the last several years, so we have a bank of resources that are available. All the webinars are recorded, including today's. And then you can also take a look ahead and see what we have scheduled for the calendar year of 2019. We have some months we'll double up and have multiple, but we do have webinars scheduled all the way through December. With that said, I'm excited to introduce our two speakers for today. Our webinar is, the title of our webinar today is Noise and Light Pollution, Tools to Prioritize Locations Where Restoration or Mitigation Would Yield the Greatest Benefits to Visitor Experience and Resource Conditions. We have two NPS staff members who will be presenting today. Kurt Fristrup is the Branch Chief for Science and Technology for the Natural Sounds and Night Skies Division. And we also have Sharolyn Anderson, who is a physical scientist with the same division, Natural Sounds and Night Skies, both of whom have an impressive background. They both have PhDs. Kurt's is in organismal and evolutionary biology from Harvard University, and Sharolyn has a PhD in geography from Arizona State University. With that said, I'm going to go ahead and jump in, acknowledging that we want to be mindful of everyone's time here. If you have questions throughout the presentation, feel free to use that chat box, and we'll be monitoring that throughout the presentation. So if there's a question that makes sense to ask during the actual presentation, we'll go ahead and open it up for the question at that point. And if not, we'll wait until the end. And we do have the ability to open up all the phone lines at the end as well. So if you have a question that you'd like to say aloud rather than plug into the chat, that's okay too. That said, I'm going to go ahead and turn it right over to Kurt and Sharolyn. Thanks again for joining us. Looking forward to your presentation.
Thank you. We are grateful for this opportunity to participate in the Connected Conservation webinar series. And thanks, Cass Hardy, for stepping in to host us and giving us such a wonderful introduction. We are excited to be here from the Natural Resource Stewardship and Science Directorate, and underneath that is our NSNSD division, which is on the slide. I'd like to tell you a little bit about our three main areas of work. Hold on, I am going to tell you about our three main areas of work, and they basically are we're looking at collecting data in the fields. We model both light and sound pollution, and then we recommend best practices. And I think it's important to remember that all of these three methods, we actually started with number 3, and the question of how can we best help the parks, or how can we recommend practices for conserving these resources of both the starry nights and the natural sound. And today's presentation is a little introduction to who we are, so a beginning of our origins, how we take our measurements of our data and collect our data, give you a quick inventory status, and that'll all be given by Kurt, and then I'll jump in to do some geospatial models and explain how they are, and then he'll step back in to give you the effects on both wildlife and park visitorship. And then at the end, we'll talk about opportunities for restoration and mitigation. Kurt?
Hi, this is Kurt again. So we derive our authority for doing this kind of work from several sources in legislation. Of course, the Organic Act of 1916, which mandates the conservation of all resources, of which light and sound are two. The Wilderness Act has several explicit references to conditions like solitude that are affected by light and sound. There are two acts of Congress that specify that Americans should be able to live in environments free from noise that affects their health or welfare. Well, welfare is more broadly defined. There's explicit reference to light in terms of defining critical habitat for endangered species. And the Grand Canyon Enlargement Act is the first time when, in legislation, the Park Service and sound were explicitly linked. It recognized natural quiet as a resource and its value to be protected at Grand Canyon. And lastly, very specific legislation deals with the management of overflights, of flight seeing over national park units in relation to managing the noise impacts on the ground. So the Natural Sounds program, somewhat ironically, has sort of moved from left to right in this slide, dealing with first the air tour noise issue at Grand Canyon and the winter use vehicle noise at Yellowstone, and then gradually expanded to more air tour parks and to more noise sources that occur within and adjacent to park boundaries. The night sky story is a bit more eccentric and, to me, heroic, in that Dan DeRisco and Chad Moore basically started applying for project funds in the late 1990s to address this concern that light was encroaching on the integrity of park night skies. And in 2003, they did something that I think is remarkable in resigning their FTE positions to pursue full-time work on this topic, relying on these kinds of project funds. They were able to maintain funding and be extraordinarily successful. They developed the world-class leading measurement system that we're going to show data from in 2005. By 2009, they'd been successful enough that NRSS basically, enveloped them like an amoeba absorbing food. So they became part of NRSS, but it wasn't until 5 years after that that base funding was actually allocated to the program and we could hire FTE into the Night Skies team. Ironically, that next year, Dan DeRisco retired and Chad Moore moved on to the Bureau of Reclamation. So this amazing team that they helped create, just at the time when it became sort of institutionally funded, they moved on to other pursuits. So night skies data collection is actually quite tricky, not only because you're working outside at night, but also because you need very specific conditions. You want to minimize any lunar illumination of the sky to eliminate that source of measurement complexity. You also need clear skies, not only no clouds, but minimal smoke, if possible, the lowest possible humidity levels. Everything that you can have to maximize the transparency of the air is critical. So for any given park unit or site in the United States, there might only be, a handful of nights each year where the conditions are right for making measurements. And the Night Skies team goes to great length to identify a suite of possible options for each new moon cycle. And then literally, they file multiple travel authorizations, and we make a call, 2 to 3 days in advance what the weather forecast says to choose the actual site where they'll do the work. This next animation will show you what the camera does in operation. So they have a computer-controlled mount that swings it around, and it takes 45 images of the night sky. The reason this is important is actually that outer ring, which has just been shot, because sky glow is most intense near the horizon. So if we want to pick up the earliest indications of light pollution beginning to affect a night sky in a park, that outer row of images will be the ones that give us the most sensitive measurements. Sound measurement equipment also has its complexities, and in the beginning, this picture was taken in 2007. It took several people to carry the equipment into a site. There was basically a laptop computer involved, and we had to have a solar-powered system there. We couldn't hike in enough batteries to make it run for a month, so we had to have a solar charging system. It was quite a mess to arrange, if you will. By 2009, Damon Joyce had made a number of improvements in our system. And you can see that essentially what we use today, he'd reduced the weight of the system by a factor of 8 and the power consumption by a factor of 10, which means, like as in this site, we can actually run it for 30 days without any solar or wind power. We can just run it straight off batteries. By the way, these measurements in 2009 at Great Sand Dunes documented such extraordinarily low natural sound levels that a circuit court judge issued a permanent injunction against energy development on the borders of the park. So our data sometimes do have real-world significance. There's a little box in which Damon has now organized and managed all the pluggery and cables that go along with our system. So we can deploy our equipment anywhere, anytime. We don't need clear skies or moonless nights. But that does mean sometimes in our efforts to document all the full range of weather conditions in a full range of parks, that sometimes our field people are operating in challenging conditions for operating electronics. So here's a quick look at what the data products look like, the sort of alpha level data products. The top image here from Chaco Cultural Natural Historic Park gives you a false color rendering of all of the light in the night sky. So you can see the Milky Way arcing from south over to the left to north in the night sky. And you can also see the non-natural part of the scene on the horizon. You can see those little balls of light or little domes of light coming from the communities. Those of you who know Chaco culture, you'll know there aren't any communities very close to the park. And if you go to the bottom half of this slide, you can see the communities identified with those respective light domes. So the big message here is that, you know, light and sky quality are one of those park resources that can be affected by activities that are tens to hundreds of miles away from park boundaries. This is an example of what our sound level data looks like. This is one day in the life of Bryce Canyon from 2003 in November. In the upper left corner, we have midnight, 2 hours in each of the rows you see here. And on the vertical axis in the slide, we have frequency on a logarithmic scale. So the lowest tick mark you see is 10 hertz, then you see 100 hertz, then you see, sorry, that's actually 40 hertz, 400 hertz, and 4,000 hertz. The most common signature in this slide, I don't know if you can see my arrow, is this sort of blob. That's a high altitude jet overflight, either freight or commercial passenger traffic. If you average across the entire national park system, overhead jet flights like that are audible about 25% of the time in national park units. You can also see in this slide that there's some wind that starts picking up around 7 o'clock, becomes most intense between 9 and 11, might even involve some precipitation on that day. You can see a little bit of a bird song chorus here, starting just before 1 o'clock and extending almost till 2 o'clock. Remember, this is the winter time, so birds aren't singing first thing in the morning. They tend to pick times during midday when it's a little more temperate. You can also see a few fixed-wing aircraft here, propeller-based aircraft that are flying at lower elevations. Now I'm going to fade to a different image of the same data. Humans are much less sensitive to very low and very high-frequency sound, and when you take into account the human thresholds of hearing, the absolute sound level data you just saw translates into this image, which is a better representation of what a person on that site would hear. So that's a quick look at the kinds of sort of initial data products that come out of our monitoring. I'm going to transition from this sort of local scale and local measurements back to Sharolyn, who will talk about the tools we've created for sort of large landscape analyses.
Hi. I'd like to just note that we've gone over the origins of the department, how we've got our measurements, and now we're at the inventory status. And we currently have 303, which are the red dots on the map, 303 sound measurements on the continental United States. For those of you that are in Alaska and Hawaii, we do have monitoring sites there, both for sound and sky, but our models right now are being worked on for those areas. So I'm going to be focusing on just the continental U.S., but they are always part of what we're thinking of. And for the night skies, we have 176 points. As Kurt mentioned, those nights are a little bit more difficult to get your data. The sound has its own problems. Of at least every one of those red dots meant that field equipment was in the field for over 28 days. So this is where we have our actual field locations. And as you can see, it's a pretty nice coverage, given that this is a newer division. But if you look in the Midwest or you look in the northwestern part of the U.S., we are lacking a few areas of for data or information. So the geospatial models, the first one I'd like to talk about is the light levels or night lights model. And what we do here is we start with satellite imagery. One of the great things about this imagery, which is basically the day-night band from the VIIRS satellite, is a satellite, think about it, it's up top, and it's actually getting all of the light or the radiance directly up. So it's the satellite's collecting the data or the light above it. So it's kind of think of it as going straight up. And those are your sources. So you can tell here from the VIIRS raw data that the sources are pretty urban-centric, right? But if we take and extract some of this information and do some fancy remote sensing, as NASA did with their Black Marble data set, you actually can see that there's more information or data within the satellite data set than can be seen with the naked eye. We took these data and then we basically created a model or a tool, in this case, if you want to think about it that way, which is a landscape model of the all-sky light pollution ratio. So I call this the ALR model. And this model basically takes that information, that source data that the satellite picks up going straight up in the air, and it spreads it across the whole sky. That's what the model does. And this model is both an empirical and theoretical model that allows us to look at the spread of the light across the landscape. So for those of you that are in the Denver area or Fort Collins, where we are, you can see this is the Front Range area, and you can see that it spreads all the way across the Rocky Mountain National Park. And so the spread of this is really what we're looking at, and you can see that the sky glow affects much more of the landscape than initially believed when you look at the satellite data. Now, if we're looking at the sound landscape or the sound models, it's a little bit different because we don't have a satellite, so we don't have full coverage of what is actually happening. And so we work from ground measurements. In addition to those ground measurements, we've included about 100 different variables from land cover, hydrology, wind speed, and a number of continental data sets to actually come up with simulations or models of the landscape. And the one that you're looking at right now is the natural landscape. This is what it would look like without human additions to the soundscape. And the neat thing about this is we can, from having developed the natural sound levels, we can then look at the anthropogenic noise that is added to this. And so with this model, this is about the average noise across the continental United States on any time. And so this is great because we have these two models, and these models allow us to look at the larger picture and allows us to work with adjacent communities, and it allows us to look at sources outside of our park system and how that might influence what's inside the park, right? And so this gives us a nice tool to work with our communities and work with outside sources, but it also tells us what those sources outside are affecting the park. One of the questions of the park system is, what can we do within our parks? So within the parks, we have this exploratory graphics that we created just for this talk, and basically these graphics are telling you from inside the parks, right? And I'd like you first to look at the color. So the color's darker. That's telling you that the percentage of the area of the park is bright or not bright. Okay, so the darker the circle, the darker the park. And the lighter the circle, right, the brighter the park. And as far as the size of these circles isn't the area of the park, but it's the area of the circle that has some light in it, proportional to seeing how much of that park is actually lit or not lit, right? So this gives us some information that we can use within our park to take action. And we can do the same thing a little bit differently, but we can do a similar study with what the sound levels. So in this case, we're looking at traffic and air noise within a park. And these circles are based on the size of the park. And in this case, the darker the circle, the louder the park. And the lighter the circle, the quieter the park. And that gives us this idea of within the park itself, these are the parks that we want to concentrate on when we're looking at reducing the interior source of either light or sound pollution. Lastly, I'm going to talk about looking at these tools and using them for both external and internal information to help guide management and mitigation on either sounds or light. And in this case, this is a product that we produce for the parks that shows the park itself. In this case, we're back to Chaco. And you can see that Chaco itself is in a darker area, right? But it's surrounded by very lit. And this is sky glow. And if you remember back when Kurt was talking about the products that we got in the field, you can now see those areas and how far the light will spread from hundreds of miles away. Okay, and what I'd like to do now is transition back to Kurt, who's going to discuss some of the effects on wildlife and park visitors.
Thanks, Sharolyn. So just to emphasize her last point, we like to show the continental-sized maps to give you a sense that we have coverage everywhere. But when you zoom into any one of those maps, you can reveal a lot more detail that might be pertinent or important for parks to consider when they're thinking about where and when they're going to address some of these issues. Now, what unites sound and light to form this division, it wasn't just that they couldn't figure out what else to do with us. Both of these things you might term as sensory pollution. And as such, you might expect that the effects of noise and light would be fairly universal across the wildlife kingdom because all organisms sense the resources that they interact with and sense each other, you know, through vision, through hearing, also through smell and other kinds of things, which happily yet we don't deal with, but might one day. And so our expectation should be that noise and light will both have fitness and population consequences on a very wide range of organisms. We have conducted systematic literature surveys to document and summarize the extent of the evidence that we have in hand. And as you can see in this slide, across a wide range of light exposure levels, there are papers documenting effects on a wide range of taxa. And as I said, the biological presumption would be that since organisms are highly attuned to changes in light level from new moon to quarter moon to half moon to full moon, and those things tend to drive a lot of circadian rhythms in activity and physiology, we should expect that we'd see significant responses, both behavioral and physiological, when we add light to scenes and change those natural light cycles. On the sound front, most of the literature prior to the year 2000 was focused on the behavioral and physiological responses of animals to very loud and brief sounds. So like military overflight effects were driving a lot of that literature. And it's only been really in the last 10 years, in no small part due to the activities of this division, that biologists are beginning to focus on the effects of much more subtle but chronically present exposures to noise. So you can see here the summary of the papers published and the taxa that involved that were affected through 2013 when we published this literature review. And I can show you that you can see even in this graph the relatively rapid growth in this literature, but in the 3 years since the literature, this exponential growth has continued. And it's now really actually quite challenging for our division to keep up with the incoming flood of information documenting the biological consequences of noise to wildlife. I want to emphasize right now that this is not meant to be, oh wow, there are two new sources of bad news for wildlife. I mean, while you could take it that way, I think the more constructive way to think about this is these are actually two factors that affect wildlife that we can change instantly. As soon as you're able to address either the source of light or the source of noise, you have an instant improvement. There's no matter to try and pull out of the environment. There's no problem with carbon dioxide reservoirs in the atmosphere and climate change. We can make a change with these things immediately, and there are a wide range of engineering and technical options for making a difference in these areas. So I actually would for myself, project this as sort of the size of the opportunities we have going forward, not just 2 more sources of bad news. So on the light side, there are a number of things going to be driving changes in lighting in this country. One of the big ones being economic, that basically the changeover from traditional lights to solid state lighting has a payback time of 4 to 5 years, because the new generation lights use a lot less electricity and last a lot longer between maintenance visits. So the change is going to happen. What kinds of principles can parks and partners use to guide their selection of solid state lighting? In the first 4 bullets, you see some common sense suggestions that you should only light places that really need it, and only at the times of day or days of the week, and in the locations in park units where you really need the light. You should need to think about the spectrum of the light. That's especially important for potential impacts to insects and other night flying animals. You want to minimize the amount of light you use. I think the physician's dictum to say first do no harm should apply to nocturnal lighting. Even in the absence of explicit information for that location, it would probably be a good first assumption that stray light's going to be affecting some park resource or some wildlife. And lastly, of course, the whole point of switching over is also to reduce our energy consumption and carbon footprints. There are some things you can do, common sense you can do to assess whether your scene lighting is sort of good today, by just walking outside and looking at your park setting. When you look at a setting, you should have light. Again, there should be enough light around to let you to orient and to navigate safely, along paths or across parking lots. But there shouldn't be any place in the scene where you look and there's a markedly brighter source, like a point of light or a very brightly washed wall, that actually affects your capacity to see the rest of the scene. So glare, the fact you can actually feel uncomfortable when you look at some light sources, is a sign that you have a sort of acute problem to address if there's any glare in the scene. But you also want to look more generally and make sure that as your visitors or your staff are transitioning from lit to unlit areas, they're not going to be momentarily night blind as they leave. My personal observation as a visitor to many public lands areas is that, for example, our comfort stations are way, way overlit. And I'm sure many of you have had the experience of going into one at night and coming out and transitioning into an unlit area and having to wait some minute or two for your eyes to readjust to the scene. Of course, the other thing that we lose when we've been exposed to a glary light source or to excessive illumination, we look up, the number of stars we'll be able to see. Even if there is no sky glow, if we're not lit properly in parks, our capacity to even see the night sky has been compromised by our degraded night vision. So I'd like to show some examples of successful park upgrades and lighting. So here you see Chisos Basin and Big Bend National Park. Note in the upper photograph that you can see the entire mountain front, the front of that ridge line behind the developed area is all lit up by the lights in the original lighting scheme. And when they upgraded, you can see down below in 2011, that illumination all went away. And even the sort of visual salience of the lit area, developed area itself, diminished substantially. Both of these images, by the way, were taken with a calibrated camera at the same exposure level. So this is a true representation of change in lighting. And this gives you an idea of what it looks like on the ground. What you can note in this scene is that the lights on the building are actually themselves not visible. You can see the wash of light on the wall, but you don't see the light sources themselves. The bollards that you can see illuminating the path, there you can actually see the sources themselves, and that may have been intentional, but I would note that in many park settings, the optimal lighting scene might be one in which you can't see any of the lights themselves. There could be a potential sort of conflict of interest here, or conflicting desires. some park managers or some lighting designers might see light sources as a potential for sort of ornamentation. But we have to weigh that, I think, against the potential costs in terms of effects on visitor dark adaptation and the sort of stray spread of those the photons from those fixtures. Here's another great example from Stovepipe Wells in Death Valley. In the upper one, you can see the trees behind the buildings are brightly illuminated, and there's a lot of glare in this scene. When you switch to the lower picture, you know, all that stray illumination on the vegetation's gone away. Interestingly, in the bottom picture, what are the brightest sources of light in that scene? It's actually those windows. And so that suggests that in some more sensitive park environments, we actually might need to think a little bit about interior lighting and window treatments that might help prevent the escape of that light into environments we are concerned about. On the sound front, I'd like to emphasize first the link you can see in the middle of this slide. The National Academy of Engineering worked with the Park Service to come up with a guide of engineering solutions for how to reduce noise sources inside parks. That ranges everything from the title of this slide, the backup alarms on trucks, through quiet pavement options, into all kinds of other quieter equipment options. And the substance of the slide, the bulk of the slide addresses an initiative that David Betchkal, our Alaska regional employee, undertook at Denali to replace the tonal backup alarms on their heavy equipment with these more subtle broadband backup alerting systems. And you can see on the right-hand side our prediction of how much less park area is affected when you use those more environmentally sustainable backup alarms. There's no compromise here in the safety of the employees behind the truck who need to be alerted when it's backing up, but there's a dramatic reduction in the sort of unintended impacts to adjacent park resources. And that concludes our talk. We try to leave some time for us to interact with you about conversations. And here's our current staff, and we welcome any questions you have.
Great, thanks so much, guys. We do have one question that's in our chat box, and folks, if you do have questions, feel free to go ahead and plug them in there at this time. We'll go through them first, and then we can open up any of the lines. In demonstration of light and sound maps, you implied these are available for parks to use. Can you provide the appropriate hyperlink to the maps?
Yes, we can. There are actually multiple hyperlinks, and trying to think, like we could put one up right now, but it might be best if you would reach out to Sharolyn to get the latest link and possibly the latest guidance on how to use those. So the answer is all the sound level maps are up in IRMA, the data store. The light map may not be. Right?
No, the light map is up on ArcGIS online, so I can just send a link to whoever needs it, and they can download it, and there's a how-to-use paper with that. So yes, we would love to have people using our data. So we're happy to share it.
And we have shown one on the sound level side. We have actually, I think, 9 map products that are out so far. So you might want to talk with us briefly about which of them would be most appropriate for the issues you'd like to address. On the light side, there could very well be additional products emerging. So to get the latest information, I would recommend just reaching out to Sharolyn. She's usually quite responsive.
I try to be.
Mm-hmm. Great. And because there's actually over 70 people on the webinar right now, and I think it might get a little crazy if we open up all the lines. So if you do have questions, please do use that chat box. I think it'll be far more effective. So we'll give it another minute and see if anyone else has any other questions.
And by the way,
one that just come. Go ahead, Kurt.
Well, I was just going to say, Sharolyn will reach out to Charles directly after the talk to provide those links.
Perfect. Another question that's come in is, have other countries' park agencies done work in natural sounds and night skies?
Yes, none quite as extensively as we have done. So we have consulted with park managers in South Africa and Italy and France and Denmark and New Zealand thus far. There is emerging European Union guidance on noise and light that is trying to address the sort of overall environmental burden of human activities. So they're actually taking action on a sort of subcontinental scale there from an administrative or regulatory perspective. So I guess what I would summarize to say, there's probably, we've done a little more, been more active in the data collection, analysis, and impact assessment here in the United States, but actually there may be more action on the regulatory front abroad.
Great, thanks, Kurt. A few more that have come in. Are there specifications available of the light fixtures used in the conversion projects that were shown?
Yes, we can get those for you. Since that conversion took place nearly 10 years ago, it's very likely that those particular luminaires are no longer available, but in fact, the range of commercial options, consumer options available has just expanded dramatically. Fortunately, the Department of Energy hosts a solid-state lighting website that provides access to a huge database of manufacturers, luminaires, and light sources. So I think, again, if you're interested in this kind of issue, please contact us. We'll help you. You know, those are not trivial tools to engage with for the first time. So we'll help you as best we can there and provide some, additional sort of commentary about which specifications to pay attention to and how to efficiently winnow down your search to the luminaires that are likely to be most useful to you. I guess I should also say we're in the process of trying to hire a lighting specialist, a physical scientist who will specialize in lighting and light measurements sort of within, on the local scale, within the park boundaries and within the visual horizon. And so shortly we should have a little bit deeper bench in this area.
Great. We'll make sure that your contact info goes out to all participants after the presentation today too. Quite a few more questions, Kurt and Sharolyn. Can you comment on chainsaws and other fire-related tools in parks, such as electric battery conversion, for example?
Yes, so we have a tool. Once again, contact us, but we've actually done some product surveys of alternative equipment, looking at gas-powered equipment and their sort of quieter options. Well, I should even say, even within the gas-powered equipment category, there can be a wide range in sort of sound level outputs. So we have an older print version of this document, which compared a range of equipment choices for those kinds of equipment categories. And we're working with a research systems group to come up with an updated online version that is more readily updated as new models hit the consumer market. So yes, for chainsaws and many other things, there are electrified, rechargeable options available now. And even within, if your power demands are higher and you still need, the more power than an electrical system can generate at the present time, we can also put you on to gas-powered systems that have much lower sound output levels.
Great. And our next question is focused on policies. Is NPS rewriting its policies or building specs to require low-impact best management practices?
So we have a wide range of draft policy documents here in the division that are in various stages of review, and I won't even say we haven't, none of them is close to implementation yet. But we're also engaging directly with the Development Advisory Board and with PPFL, the Denver Service Center, to make them aware of the rapidly evolving technological landscape and also the emerging evidence about impacts to park resources, so that those designers and planners can make direct use of some of this information in advance of any kind of programmatic or systematic policy establishment.
And our next question is, you show the results of a literature review on the effects of sound on wildlife. Are you aware of any similar synthesis on the effects of artificial light on wildlife?
Yes, so I didn't, the paper has not yet been published, but I'm going to back up just a couple of slides here. Oh, yes. These figures are from a manuscript that should be submitted very shortly. It's a paper, and I can provide a preprint for those in the audience. If you mail me, I'll get you a preprint of it, where we basically have done a global analysis of light exposure in protected areas. So that, of course, includes all the continental United States as well, and related the exposure levels in those parks to these thresholds of biological response. And that this literature review for light spanned about over 600 papers. And I should emphasize, for both literature reviews, what we did was establish a standardized search criterion that can be repeated over and over again, so we can actually find out within a certain segment of the scientific literature how rapidly is the literature growing and changing, and what topics are emerging over time within that sort of topic area. So yes, if anyone's interested in this, I can get you sort of a preprint or advanced copy of this short paper. And we're working on tools internally within division to try and make these annotated literature surveys broadly available to parks, so that instead of having to conduct the searches yourselves, you can actually jump into some kind of web-based database interface on our web pages where you'd see the papers, you get some sense of the overall shape of the literature in terms of topics, and then be able to drill down as you like into the references and summaries of particular papers.
And Kurt, kind of along those same lines, one question is also focused on wildlife-friendly lighting. This person specifically asking about insects. Are there color temperatures recommended for different species?
Well, so that I agree with that person that this should be a dominant consideration for park managers. The color temperature specifications for lights and luminaires are helpful, but a little bit misleading in that, so there are no hard and fast rules about what's not good or what's good. A lot of the guidance you will see says, like from the International Dark Sky Association and others, will say that you shouldn't have a correlated color temperature above 3,000 Kelvin. We've gone out and made spectrographic measurements of lamps, luminaires like that, and there's still a fairly prominent spike of energy in the blue part of the spectrum. And I should make it clear that all of these solid state lights we're talking about, all of them are based on a blue LED source, which has been coated with chemicals that absorb the blue light and radiate a broader spectrum of longer wavelength light. And so the nature of those chemicals and how much you put there determines how much of that blue light sort of residue leaks throughout the environment. So I've also seen a Canadian company demonstrate a fairly bright white looking light that has a correlated color temperature of 2200 Kelvin and almost no blue spike in it. So for insects, blue and ultraviolet are the big game in town. In fact, that's the way a lot of entomologists go out to collect insects. They'll project a bright blue or ultraviolet rich light onto a sheet and attract them by that means. So yes, I'd say that's the biggest and possibly the least documented impact of light on park resources is the potential massive removal of insects from ecosystems due to exterior lights that serve as traps.
Great, and just two more questions, although there is one comment about the Advisory Council for Historic Preservation, really enjoying the presentation, and thanking you for your help with Teddy Roosevelt National Park. So one other question though is there anything like International Dark Skies Parks for natural quiet places?
So there's an advocate named Gordon Hempton who established the 1 square inch of silence up in Olympic National Park and has been using that as a tool for public education and outreach. And he recently contacted us, and he and several other people are putting together, I think it's going to be called Quiet International, but they're actually putting together an organization modeled on the IDA that will be trying to help parks and protected areas understand the value of protecting their parks against noise intrusions, standards for certification for achievements for different kinds of parks, and guidance in terms of how to reduce noise and mitigate against its effects. So that's coming together right now. Will probably be publicly released out into the public in the next 6 months or so. And I have been contacted to serve as part of their standards development group to try and decide what the appropriate standards are for certification. So stay tuned on that front. I suspect there'll be something emerging into the public view within the next 6 months.
Great. And our last question for you guys, and John Putnam actually just plugged in quietparks.org as a link that might be useful for others who are interested in learning more about that. Last question here, and we'll wrap it up. Have you developed any model regulatory documents, or are you working with partners to produce ordinances? So the International Dark Sky Association has worked with the Illumination Engineering Society to come up with a model, is that a model ordinance or a model design criteria? But they've come up with a document that helps create or direct lighting designs for protected areas. And there certainly is a model noise ordinance that's been produced by Les Blumberg, who's at www.nonoise.org on that front. So yes, there's work going on in this area. Several of us will be meeting with the IES, which is the Accredited Standards Secretariat for Noise for ANSI, and we'll be meeting with them to establish a working group to develop lighting criteria, lighting standards for protected areas and natural areas. So again, this is an area where there's pretty rapid movement taking place, and I expect there'll be products available to everybody within 9 to 12 months or so. Great. Thank you so much, Sharolyn and Kurt, for this excellent presentation. And thank you to all the participants for the incredible questions. It always makes it a little bit more interesting and gives it some good momentum to have so many questions come in at the end. So thank you again for joining us. We do have a follow-up webinar that'll be focused on dark sky parks, and that's scheduled for March 6th. And if you'd like to join us, I'm going to go ahead and plug it in the link to, again, our webinar series page. We also have an external site where we host a lot of our webinars, both recordings as well as places where folks can join us or register for those webinars with the Network for Landscape Conservation. They've been very welcoming to helping us promote our webinars externally as well as internally. So feel free to register for that webinar or any of our future ones. At this point, we'll wrap it up. This webinar was recorded, so it'll be plugged into both of those sites immediately following the presentation today. So if you know someone who could benefit from it or might be interested in learning more, feel free to point them in that direction. Thanks again, Kurt and Sharolyn, and I hope you all enjoy the rest of your day.
Thank you, Cass.
Thank you, Cass.